Here we go, with my almost voice has disappeared, thanks to Sports Day. So, we're now looking, we've seen some approximations by using the Poisson to approximate a binomial distribution. Now we're going to start looking at the normal distribution and using that to approximate both the binomial and the Poisson under certain conditions. Now, if you remember the normal distribution, this is going well, my voice might die halfway through. Here we go. So the normal distribution, as you know, is like a bell curve like this. It's beautifully distributed, and it's for continuous data. This creates issues because both the binomial and Poisson deal with discrete data. You know, you can't have, let's say, the rate of accidents on a road. You can't have 0.2 of an accident. Either you had an accident or you didn't. You can't go, oh, I had a terrible day today, I had 0.2 of a car accident. It's either you crashed or you didn't crash. Equally, binomial things like, you know, flipping coins, rolling dice, it's all obviously, you can't like have half a number on a dice or something weird. So we need some little corrections between our discrete and our continuous data. Something we called, back to here, a continuity correction. So this is what we mean. So let's say your original distribution is x is less than or equal to 6, which is obviously nice and easy. On discrete is that, 6 and lower. Now if we're going to approximate with a continuous distribution, we need to accept the fact that anything up to 6.5 could be rounded down to become 6. So in fact, when you correct it, use a probability that y is less than 6.5. Another example, prove that x is bigger than 10. So you want to change it to a greater than or equals to, so I should have a line here, a greater than or equals to thing. So this is the same as a probability that x is bigger than or equal to 11. So you've got to change it to this equal to signs first. So bigger than or equal to 11, which is going that way. So when we do a continuity correction, that becomes anything from 10.5 upwards becomes part of that. So now looking at probability that y is bigger than or equal to 10.5. So remember with like continuous stuff, the equal to sign, well, first of all, mathematically, like 6.49 recurring forever is just 6.5. That's another thing entirely. Also remember that if it's continuous and y equals 6.5 has a value of 0. So don't get too caught up with a less than equal to sign on like the continuous side of it, but it is important on the discrete side. The last example, so again, we'll make sure it's less than or equal to when we're using it. So this actually here, so the 2 is fine. Now less than 5 is the same as less than or equal to 4. So we're looking at values between 2 and 4. So 2 and 4 over here, with a continuity correction, that's going to go down as low as 1.5 and as high as 4.5. So in our approximation, we want to look for 1.5 and 4.5. Note the letters change between discrete and continuous because this will be used for the approximation. This is the original data. This is used for the approximation. You've got to change the letter because it's a different thing. And that's basically it for continuity corrections.